Sinosaurus. Sinosaurus, meaning Chinese lizard, was a tetanurine theropod dinosaur which lived during the early Jurassic period. It was a bipedal carnivore approximately 5.6 meters, 18 feet, in length. Fossils of the animal were found at the Lufeng Formation, in the Yunnan province of China. Discovery and naming. KMV 8701 was originally discovered in 1987. The specimen was identified as a new species, and was named Dilophosaurus sinensis. Then in 1994, during a field expedition, a more complete specimen was found, and was assigned to the same species. In 2003, Dong Zhiming studied the material of Sinosaurus, finding it to be quite similar to Dilophosaurus sinensis. As Sinosaurus was named earlier, by Young in 1948, Dilophosaurus sinensis became its junior synonym. The composite term Sinosaurus comes from Sine, the Latin word for the Chinese, and the Greek word sauros, sigma alpha upsilon rho omicron sigma, meaning lizard, thus Chinese lizard. The specific name, Triassicus, refers to the Triassic, the period that the fossils were originally thought to date from. Sinosaurus was described and named by Chengchen Yang, who is known as the father of Chinese vertebrate paleontology, in 1948. Over the years, paleontologists referred additional specimens to D. sinensis which are now assigned to Sinosaurus. Dong, 2003, referred specimen LDM-LCA10 which consists of a skull and an incomplete skeleton. In 2012, Singh referred two individuals, ZLJ0003 which consists of a partial skull and an incomplete skeleton, and ZLJT01 which is a juvenile individual that consists of a premaxillary fragment, an incomplete maxilla, a maxillary fragment, a lacrimal, both frontals, both parietals, an incomplete brain case, an incomplete dentary, an atlantal inner centrum, two dorsal rib fragments, and a partial proximal caudal neural arch, to Sinosaurus. The holotype, IVPPV34, was found in the lower Lufeng Formation, and consists of two maxillary, upper jaw, fragments, four maxillary teeth, and a lower jaw fragment with three teeth. The teeth are laterally compressed, and feature fine serrations both at their anterior and posterior edges. The teeth are also variable in size and are curved backwards. This material is too fragmentary to determine the length and weight of this dinosaur. Over the years, other fossils were referred to Sinosaurus, some of which were material that was shown to belong to two sauropodomorphs. The fossils include a postcrania, with a sacrum with three preserved sacral vertebrae. The material assigned to Sinosaurus postcrania includes a mix of plateosaurid and melanosaurid elements. All the material from the red beds block has now been reassigned to Jingshannosaurus. Shijinhu, 1993, assigned specimen KMB 8701 to Dilophosaurus sinensis. In 2013, a study by Curry et al. Confirmed that D. sinensis was the same animal as Sinosaurus triassicus. On the other hand, Wang et al. 2017, stated that it needs to be further investigated whether D. sinensis is indeed a junior synonym of S. triassicus, and noted that the two species are different at least in the anatomy of the premaxilla. The authors tentatively assigned D. sinensis to the genus Sinosaurus, but retained it as a species distinct from Sinosaurus triassicus. Specimen KMB 8701 consists of a skull, measuring 525 mm, and is nearly complete. The specimen KMB 8701 is about 5.6 meters, 18 feet, long, meaning Sinosaurus was about that length. KMV 8701 has been assigned now to Sinosaurus, but the specimen still lacks sufficient description and preparation. In 2012, a new specimen of Sinosaurus was described, and was found to represent a new species. Description. According to Carano et al. 2012, D. sinensis, now considered to be at least congeneric with Sinosaurus triassicus, can be distinguished based on the fact that a vertical groove is present on the lateral premaxilla adjacent to contact with the maxilla. Sinosaurus is the only dilophosaurid known from a complete brain case. Creolophosaurus, Dilophosaurus, Zoopasaurus and Colophysis chianticati are all known from partial brain cases. Two partial brain cases were found before 2012, and are probably mostly complete, except that large sections are obscured by sediments. In 2011, an exceptionally well-preserved brain case was found, only missing the frontal bones and orbitasphenoid. Classification. Originally thought to be a colophysoid related to Dilophosaurus and Creolophosaurus, Oliver Rauhout in 2003 showed Sinosaurus to be a more advanced theropod, related to Creolophosaurus and Dilophosaurus sinensis. In 2013, in an unpublished work, Carano agreed that Sinosaurus is a theropod. Sinosaurus has been considered a nomen dubium in a few works, although now that Dilophosaurus sinensis is referred to it, it is considered valid. Dilophosaurus sinensis was shown to be a junior synonym of Sinosaurus in 2003. It is possibly closer to the Antarctic theropod Creolophosaurus, based on the fact that the anterior end of the eagle does not participate in the internal antorbital fenestra and that the maxillary tooth row is completely in front of the eye socket. D. sinensis was exhibited in 1998 at Dinofest in Philadelphia. Although the skull of D. sinensis sports large nasolacrimal crests superficially like those reconstructed in D. weatherilli, features elsewhere in the skeleton suggest it is closer to tetanurine theropods. Rauhood, 2003, regarded D. sinensis as a basal tetanurine most closely related to Sinosaurus and Creolophosaurus. Lamina et al. 1998b, examined the material ascribed to D. sinensis and found it to be synonymous with Sinosaurus triassicus. This cladistic finding was confirmed in 2003 by Dong. The Lufeng Dinosaurian Museum discovered a new specimen of Sinosaurus, ZLJD01, in 2007 from the Lufeng Basin. It consists of an incomplete skull and other postcranial fragments. Phylogenetic analysis of this specimen demonstrates that Sinosaurus is a more derived theropod, and is not the most basal Dilophosaurid, as held by Smith et al. A cladogram was identified by Christoph Hendricks and Octavio Mateus. It placed Sinosaurus and Creolophosaurus in a polytomy at the base of Tetanuri. Paleobiology. Crest function. Sinosaurus and Dilophosaurus both possess dual crests. However, it was found that the crests could not be used in combat. Feeding. The skull of Sinosaurus has a deep notch between the premaxilla and maxilla. Dong, 2003, proposed that the notch was used to house jaw muscles, giving Sinosaurus a powerful bite. Based on the estimated power of its jaws, Sinosaurus might have either been a carnivore or a scavenger. Dong suspected that the premaxilla was covered in a narrow, hooked beak, that was used to rip open skin and abdominal flesh. He also thought that the crest would have been used to hold open the abdominal cavity while feeding. Dong studied the feet of Sinosaurus as well, finding a resemblance with the feet of modern vultures. The feet of Sinosaurus were probably adapted to help it feed on large-bodied animals, such as prosauropods. Paleopathology. A study by Singh et al. 2013, examined the effect of the traumatic loss of teeth on the dental alveolus, the socket in the jaw where the roots of teeth are held, in dinosaurs. Sinosaurus is the first dinosaur where remodeling of the alveolus in the jaw was observed. The authors concluded that this finding contributes to mounting evidence suggesting theropods were highly resilient to a broad spectrum of traumas and diseases. The dental alveolus found on Sinosaurus is the first documented dental pathology found on a dinosaur. Paleoecology. Provenance and occurrence. The type specimen of Sinosaurus triassicus IVPPV34 was recovered in the Zhangjiawa member of the Lufeng Formation, in Yunnan, China. These remains were discovered at the dark red beds that were deposited during the Sine-Maurian stage of the Jurassic period, approximately 196 to 183 million years ago. Several other discoveries referred to Sinosaurus were made in the Zhangjiawa member, specimens IVPPV97, postcrania, IVPPV36, teeth, IVPP37, teeth, IVPPV88, ilium, IVPPV35, teeth and postcranial bones, IVPPV100 and IVPPV48, teeth and postcranial bones, discovered in 1938 by M. Bien and C. C. Young, FMNH Cup 2001-2003 discovered by Euler and Hu. Specimens FMNH 2097 Cuban pesos, FMNH 2098 Cuban pesos, FMNH 2004 Cuban pesos, FMNH 2005 Cuban pesos were discovered in 1948 by M. Bien and C. C. Young at Zhangjiawa member, as well. Sinosaurus sp. Fossils have been found in the Zhenzhoushang Formation, and were previously thought to be a poposaur, although they might have only been from the equivalent Lufeng Formation. Specimen IVPPV504, referred to Sinosaurus, a maxilla with 4 teeth, was collected by Li in the 1940s, in the dull purplish beds of Shawan member of the Lufeng Formation, that were deposited during the Hedengian stage of the Jurassic period, approximately 201 to 199 million years ago. Several other discoveries were made in the Shawan member. Parts of 2 skeletons attributed to Sinosaurus were discovered by Su in 1956. Specimen IVPPV279, tooth, was discovered by C. C. Young in 1938, in dark red clayish sandstone, and specimen IVPPV381, several teeth, was discovered by C.C. Young, in Blue Mudstone. The D. sinensis remains, KMV 8701, a nearly complete skeleton, now referred to Sinosaurus, were recovered in the Shawan member of Lufeng Formation. This material was discovered in 1987 in the dull purplish beds that were deposited during the Hettangian stage of the early Jurassic, approximately 201 to 199 million years ago. Fauna and habitat. In the Lufeng Formation, Sinosaurus shared its paleoenvironment with therapsids like Morganocodon, Oligokyphus, and Bioenitherium, archosaurs like Pachysuchus, diapsids like Strigosuchus, crocodilomorphs like Plantognathus and Microchompsa, the early mammal Hadrocodium, and other early reptiles. Contemporary dinosaurs include indeterminate sauropods, the early Thyreophorans Bioenosaurus lufengensis and Tatosaurus eleri, the supposed chimeric ornithopod Dianchungosaurus lufengensis, the prosauropods Gypasaurus sinensis, Lufengosaurus wainii, L. magnus, Jingshanosaurus sinensis, Kunmingosaurus wittengensis, Chinchakiangosaurus chunghoensis, Yuninosaurus hwangi, Y. robustus, and an unnamed taxon, and the theropods Leucosaurus, Eschanosaurus, and Colophysis sp. Changpapa's footprints have been found in the Lufeng Formation. In 2009, a study led by Lidising found that footprints from the Lufeng Formation were unique among ichnogenera, and named the footprints Changpapa's Pereschekier. The study hypothesized that they were produced by a colophysoid. There are many possible track makers, however, including both Sinosaurus and Colophysis sp.